Let's come up with a formula for finding the area of a trapezoid. Remember, a trapezoid is a quadrilateral where at least one pair of opposite sides are parallel. So which of these quadrilaterals are trapezoids? To review different kinds of quadrilaterals instead, click over here. Right, these two quadrilaterals are trapezoids. This one has one pair of opposite sides that are parallel, and this one has two pairs of opposite sides that are parallel, so not only is this shape a trapezoid, but it's also a parallelogram. Okay, let's take a closer look at this trapezoid over here. In a trapezoid, the two parallel sides are both known as the bases of the trapezoid. Let's say this bottom base has a length b1, while the top base has a length b2. And let's also say the height of this trapezoid is h. By height, we mean the length of this line between the top and bottom bases that's perpendicular to both sides. Now let's find the area of this trapezoid in terms of b1, b2, and h. First, let's make a second copy of the trapezoid and flip it over. This side is another copy of our base down here, so it has length b1. And this side is another copy of our base up here, so it has length b2. This new shape is made up of two trapezoids, so it has twice the area as our original trapezoid. Now what kind of quadrilateral is this new shape? Exactly, this is a parallelogram. Its height is h, and the base of the parallelogram is the sum of this side and this side, so its base has a length of b1 plus b2. So what's the area of this entire parallelogram? If you'd like to review how to find the area of a parallelogram, click down here instead. Nicely done. The area of this parallelogram is the length of its base, which is b1 plus b2, times its height, which is h. So that's the area of this parallelogram. But we wanted to find the area of this trapezoid over here. Now what fraction of the entire parallelogram does this trapezoid represent? Exactly right. This trapezoid is half of the parallelogram, and that means it has half the area. So the area of this trapezoid is 1/2 times b1 plus b2 times h, and this is the general formula for the area of a trapezoid. Add up the lengths of the bases, divide by 2, and multiply by the height. So let's try out a sample problem. Here's a trapezoid, and let's say this side has length 5, and this parallel side has length 10. And let's also say that the vertical distance between these sides is 4. What's the area of this trapezoid? Recall that a rhombus is a quadrilateral whose sides all have the same length. So this is an example of a rhombus, and you can check to make sure that all 4 sides have the same length. Now every rhombus is also an example of what other kind of quadrilateral? Is every rhombus also a square, a rectangle, or a parallelogram? Right, a rhombus is also a parallelogram because both pairs of opposite sides in every rhombus are parallel. So let's take a closer look at this rhombus, and let's say its side length is s. And let's also say its height is h, meaning this perpendicular line here. Try using the parallelogram formula to find the area of this rhombus in terms of s and h, or click down here to review instead. Right, to find its area you can multiply the base and the height, so that's s times h. In this lesson, we'll be finding another formula for the area of a rhombus using its diagonals. So let's draw in the two diagonals for this rhombus. Now a rhombus's diagonals always form the same angle at their intersection. What's the measure of this angle? If you're not sure or you want to work through a proof, then click over here. Exactly. The diagonals of rhombi always intersect to form 90-degree or right angles. So let's label this as being a right angle. Next, let's say this horizontal diagonal has length A, while this vertical diagonal has length B. You might have noticed that these diagonals divide the rhombus into 4 triangles. And without changing their combined area, we can rearrange these triangles to form a rectangle. The base of the rectangle is half the length of the horizontal diagonal, so it's A over 2. and the height is b. So then what's the area of this blue rectangle in terms of a and b? Right, to find a rectangle's area, you can multiply its base and height. So this rectangle has an area of a over 2 times b. Let's just move the b into the numerator so that our expression for the area is now a times b over 2. Moving the triangles back to the way we found them, we've just proven that AB over 2 is the area of our rhombus. So in general, you can find the area of a rhombus by multiplying its diagonals and then dividing by 2. Let's take this formula for a spin. Suppose you have a kite that's shaped like a rhombus. You measure the diagonals and you find that they have lengths of 2 feet and 3 feet. So what's the area of this rhombus? Nicely done. You multiplied 2 and 3 and then divided by 2 to get an answer of 3 square feet. Let's finish this lesson with one more question. Suppose you know a rhombus has an area of 120 square inches, and you also know that one of its diagonals is 10 inches long. Try using this information to determine the length of the other diagonal.